think we can start. Hi everyone, my name is Radek. Today I want to talk about image-based recommendation system. Actually, this is only a part of our bigger image analysis project, which hopefully we'll be able to present in the next year. So first, let's talk about the data. Unfortunately, for many of people, still machine learning and big data are synonymous. This is of course not the same thing. Big data is a study about data sets so big and complex that traditional data analysis and data processing tools are not enough to dealing with them. While machine learning is a data analysis method. So, okay. Not many entities are able to provide appropriate data volume. This is because sometimes company is small, but sometimes only because bad data strategy. So we need a lot of data for machine learning, and sorry, we need a lot of data because if we have a lot of data, machine learning could be easier, but it's okay. It's okay. But often we are dealing with opposite problem. We are having lack of data. Can I say that? And there are some techniques to deal with shortage of data, like transfer learning or data augmentation. But often this is not enough. And as I said, if there is no data, there is no machine learning. In case of image classification task, we often train on all the layers on big data sets like ImageNet, which have over 40 million URLs of images in over 20,000 of categories. And then we are getting quite a good feature extractor. So we can train only top classification layers, once again, on our smaller data set. For example, here is AlexNet model, very important model for image analysis and deep learning. This is the model which started explosion of publications about papers about convolutional neural network. I split this model into two parts. In the red rectangle we have feature extractor, and in the blue rectangle we have classification top layers. So first we are learning all the layers on big data set like ImageNet, and then we can learn on our own smaller data set only these three top classifications, in this case, three top classification layers, because we have fewer weights to train, so we need we don't have we don't have to have so much data like in this like for this all layers. So yes, but the most important thing for us today is this feature extractor, because feature extractor simply translates images into feature tensors. These tensors we can put to some space and then look for the nearest neighbors. These near neighbors should be similar to the input, so we can use this as our baseline recommendation system. Now I will show some examples of this baseline system. Here we have in the first column original image. In the second column we have nearest neighbor. In the third column we have second nearest neighbor, and so on. And in the rows we have three models: VGG16, Inception V3, and Inception ResNet V2. So for classification task, the best would probably be Inception ResNet. We can get the best. We can achieve a best results with Inception ResNet, but it doesn't mean that the same will be with the recommendation task. I will show you later why. Oh, sorry, spoilers. With help of our front-end developers, we prepare some demo. I encourage you to visit our stand where you can check out our demo, how it works for different products. Here we have some free random products. Yes, and this is why I want to show you on this slide why not always the best model for classification task will be the best for recommendation task. Simpler models like VGG16 are more general, while more complex ones like Inception ResNet V2 are paid attention to smaller details. So for example, in the middle column we have aggregation map. Aggregation map is a visualization of neural network activations in the regions of the image. So on the aggregation map from VGG16 feature extractor, I hope you can see shape of this dress. It's almost visible, I hope, on this screen. While on more complex one models like Inception ResNet, it looks noisy. This aggregation map looks noisy. These visualizations are an effect of selective convolutional descriptor aggregation algorithm. This algorithm help us to create mask like in the third column. This mask we can use to deal with lower quality photos, because here we have good quality photos from the store with seamless background, and this mask will help us with photos from user, for example, made by smartphone or something. And this is where fun begins, because this, as I said, this baseline system works quite well on good quality photos with seamless background. And now we are working on researching semantic segmentation, Siamese neural networks, fine-tuning on datasets like Polyvore or Street to Shop, or algorithm, as I said, selective convolutional descriptor aggregation. You can try by yourself on your own data. We prepared a repository with minimal working API written in Python. Here is a link and QR code. There is also a second repository you can find in the README, link to that. This is a research repository with some Jupyter notebooks to have fun with if you want. There are notebooks for exploring Polyvore dataset or researching a recommendation system. So how to use it? I've done my best to make it as easy as possible. First, we need to install Python and TensorFlow. I suggest to follow instructions on the TensorFlow website, how to install it, especially if you want to run this on GPU, which I'll also recommend. And this is probably the most difficult part. Then we need to install requirements, prepare a CSV file with IDs of products and paths to image in format like this, IDs, path to image. Then we need to generate recommendation space using generator py script, and now we can run server. Now you should be able to send request to this server, and in the response you should get a list of IDs of recommended products. More details can be found on GitHub. There's also some information about how to use different models, because using this generator py script you can use these three models with or without selective convolutional descriptor aggregation, and check which one will be best for you. There is one question left. Why would you even want to use a recommendation system like this? So in my opinion, the most important advantage is no need for any a priori data, except of course images of products. If you start to using this system, you can collect data from the user and fine-tune a model to increase conversion. And for some people, probably the most important advantage, getting extra hype points because of using machine learning solutions in your store. Once again, I encourage you to visit our SNOW.DOG stand, where you can check out our demo, ask some questions, share ideas, maybe join our research if you have some interesting data. And I think that's all. Thank you very much for your attention.